Okay, this video is to show you how to write these piecewise functions in DeltaMath. All right. So I'm going to show you an easier way to do one than what DeltaMath shows you how to do it. Because if you look at the answer or show an example, it's going to say find the zeros. And we haven't reviewed that yet. That was something from Math 1 and Math 2. So I'm going to show you a way to get through these so that you know what you need to do. So for instance, in this one here that says absolute value as a piecewise function, it says write the following absolute value function as a piecewise function. So what I suggest is you come to Desmos and you type in the function. Now you can use the shift and the bar key over on the right of your keyboard, or you can use the built-in Desmos keyboard to graph this. So I have the absolute value of 3x plus 9, which I've graphed here. And I can see my graph. And I can see here that my transition point is at -3, 0. So as we discussed in class, this is going to have a negative slope. This one's going to have a positive slope. So what I need to do is imagine this without the absolute value bars. I'm going to put a negative in front of one of them and distribute it through. And then the other one I'm going to write just as it is, and its transition point is going to be at -3. So this is going to be as long as x is less than -3, and this one's going to be as long as -3 is less than x. And one of them just needs to be equal to, because that point is included. So for this first one, this one needs the negative slope. So I'm going to say -3x minus 9. And this is going to be as long as x is less than -3. For the other one, I'm going to make it a positive slope and say 3x plus 9, which is the way it is if I just drop the absolute value. And this is going to be if -3 is less than or equal to x. I'll submit my answer, and we're correct. Now there is one more type that I want to show you, so let's keep practicing, because these we probably will not have worked with in class, and this is the absolute value of a quadratic function. All right. So again, same idea, except what we're going to need is we're going to need 3 rules in our piecewise function. So I'm going to come to Desmos, and I'm going to graph it. So again, I've got f of x is equal to the absolute value, and let's see what we have. We have x squared plus 9x plus 18. So I have x squared plus 9x plus 18. And so these points where it's hitting the x-axis, these are the zeros that they're talking about. I believe they're looking for you to find them algebraically. We're not going to worry about doing that because we can get them easily enough from Desmos. So what I've got is I've got this piece that's coming in. And so this is going to happen as long as x is less than -6. And that's if I drop the absolute value bars. That's what the function would look like anyway without the absolute value bars. The piece that's being changed is this bit right in here. Normally it would be coming on down and connecting those two pieces. So this is where I'm going to change all the signs for my quadratic function, is between -6 and -3. And then it's going to return to the original function when x goes beyond -3. So let me show you what that looks like. So again, we're going to just drop the inequality signs here. And that lower point was as long as x was less than -6. Then for the middle part, this is the part that was going up above the x-axis. This is the part that's been inverted. So this is where I have to apply the negative sign to each of the terms. And so I'm going to make it -x squared minus 9x minus 18. And for this bit, I'm going to say that -x is less than or equal to x, which is less than or equal to -3. Then we return to the original function if it hadn't had absolute value bars. So we're going to do the same thing as the first rule. We're just going to have x squared plus 9x plus 18. And here we're just going to say that -3 is less than x. So again, these two pieces are from the original function had it not been modified with absolute value. This is the bit that, had I not had the absolute value, it would have dipped below the x-axis. So now I have to reverse it because it's got to stay positive. And so these are the x values where it would become negative. So I'm going to say, you know what, let's just make them all positive. That way they stay above the x-axis. And so I'm going to submit my answer. And there we go. So that's how you'll do a quadratic one. So in this video, I've shown you how to do a linear one and a quadratic one. They both start with graphing in Desmos. Pick out those transition points, and then write your piecewise function. So again, a linear one would only need 2 pieces, like we did in the first example that I showed you. A quadratic one, meaning it has an x squared in it, needs 3 pieces, like we did here. Hope this helps. Go ahead and work on the DeltaMath, and I will see you in class.